In this video, we will introduce the idea of equilibrium and then also apply the, what we know about forces to solve some problems that involve equilibrium. At this point, everyone is expected to know Newton's laws of motion. And in class, the last block, we also applied Newton's laws of motion to a few simple problems. Okay, so I just wanted to take a slight detour from those problems which were non-equilibrium problems, and that'll make sense in a little bit, and then focus a little bit on equilibrium problem for today's class, and then when we get back to the next block, we can resume normal activity again. So let us define what equilibrium is. See, so far we know, according to Newton's second law of motion, that F net is equal to ma. If a is 0, okay, then we say that the object is in equilibrium. Okay, now this means that anytime a system is in equilibrium, the net force acting on the object is going to be 0. Okay, now we know that you could have multiple forces acting on the object, and so the statement F net equal to 0 means one of these two things. It means that the vector sum of all the forces acting on the object, okay, they're all going to be equal to 0. And we can further break this down and say that, hey, if the vector sum of all the forces is 0, then we know that the x component of all the forces will be, the sum of the x components of all the forces will be 0, and the sum of all the y components will also be 0. So this essentially, in a two-dimensional system, gives us two equations, and we could use this to solve most of our unknowns in the problem. The idea will become clear once we do, once we tackle a simple problem. So let's first start with something really basic, and then we will add more complicated stuff to it. Okay, so this is something that we already did in class in the last block, but let's just use this as our starting point, and then let's base everything off of this problem. So if you have a block that's hanging from a string, let's say that the mass of the block is m, and one of the things we can ask is, what is the tension in the string? And in order to calculate the tension in the string, we're going to use the idea of equilibrium. In this case, the entire system is at rest, and so again, like what we did in the last block, we can start drawing our free body diagram. So at this point, I would want you to pause and draw your diagrams, or draw a free body diagram, and then come back and check. Okay. Okay. So I'm assuming that you did that, and here we are. So the forces are going to be the weight of the object pulling it down, which will be m times g, and then the force of tension in the string pulling it up. Now what we know, since the object is at rest, we can go ahead and set up our equation. Okay, we do not have to worry about an acceleration, and so our equation is very simple. And since we only have forces acting along the vertical direction, the net force, okay, F net along the y direction is equal to 0. This simply means the summation of all the forces along the y direction is equal to 0. In this case, we have tension pointing up, mg pointing down. They are opposite each other, and so we can have T minus mg equal to 0, and therefore T is equal to mg. Okay. Now, if you thought this problem was very simple, it is very simple. You could have just done this in your head. You didn't really need to draw all these things, but it's a good starting point for the next problems that are going to arrive. Okay, so at this point, we'll pause from this one. In the next video, we're going to look at a slightly more involved example and calculate forces where things might be in simply not in more than one direction.